Hello, friends. I am Satish Lele. I am a chemical engineer. I am working in the field of piping for the last 30 years. This video is part of my chemical process piping channel on YouTube. This video is about hygienic piping. Hygenic piping finds application in food, farm and beverage industry. Due to the increase in automation, online CAP has come into existence in these sectors. In hygiene systems, a lot of time is spent on process engineering and two-thirds time is devoted for the cleaning and disinfection process. All surfaces in contact with the product like food must be immune to the product under the conditions of use, and product must not be caught, likely to or be absorbed by the product. Industries serve goods such as milk, skimmed milk, processed cheese, whey, ice cream, food such as cooking oils, fat, sugar/sweeteners, eggs, meat and poultry. Beverage such as beer, fruit juices, soft drinks, wine, coffee, pharmaceuticals such as biotechnology, enzymes, cosmetics such as soaps, detergents, industrial such as textile sizing, paint, inks, resins, chemicals, plating and photographic solutions. Beverage such as beer, fruit juices, soft drinks, wine, coffee, pharmaceuticals such as biotechnology, enzymes, cosmetics such as soaps, detergents, industrial such as textile sizing, paint, inks, resins, chemicals, plating and photographic solutions. All surfaces in contact with food must be smooth and non-porous so that tiny particles of product, bacteria, or insect eggs are not caught in microscopic surface crevices and become difficult to dislodge, thus becoming a potential source of contamination. Mechanical considerations of the cleaning in place process are seldom of significance. Adhesive forces must be considerably reduced during cleaning. This is most often accomplished chemically. Surface active detergents have to be able to overcome capillary forces. The composition of the ions in solution also influences the van der Waals forces and the electrostatic forces. For pipes, standards followed are DIN 11850 or ISO 2037. The piping layout helps to determine the functional safety of the product transport. It is important that all parts of the network receive an equal intense treatment with the cleaning detergents, and that the pipe network can run completely empty. Precautions in hygiene pipe engineering. It is difficult to clean dead water zones where the vessels connect to the main pipe. The use of double-sealed weights or short T-pieces can avoid these dead water zones. Level the product in bent sections of pipe. A bend in the pipe can be avoided by stationing the supports sufficiently close to one another. Leftover product can be avoided by using asymmetrical reductions. Good sanitary hygienic design is essential if the product is to be protected from microbial or other contamination, and cleaning effectiveness is to be maximized and cleaning costs reduced. Basic principles of sanitary design. All surfaces in contact with the product like food must be immune to the product under the conditions of use and must not migrate to or be absorbed by the product. All surfaces in contact with food must be smooth and non-porous so that tiny particles of product, bacteria, or insect eggs are not caught in microscopic surface crevices and become difficult to dislodge, becoming a potential source of contamination. All surfaces in contact with the product must be visible for inspection, or it must be demonstrated that routine cleaning procedures eliminate the possibility of contamination from bacteria or insects. surfaces in contact with the product must be readily accessible for manual cleaning or is not readily accessible. Be readily disassembled for manual cleaning or if CMP techniques are used. It must be demonstrated that the results achieved without being disassembled for manual cleaning or if CMP techniques are used. It must be demonstrated that the results achieved without disassembly are the equivalent of those obtained with disassembly and manual cleaning. All interior surfaces in contact with the product must be so arranged that the equipment/piping is self-emptying or self-draining. The piping must be so designed as to protect the contents from external contamination. The exterior or non-product contact surfaces should be arranged to prevent harboring of soils, bacteria or pests in and on the equipment itself as well as in its contact with other equipment, floors, walls or hanging supports. In design, construction, installation and maintenance, it is important to avoid dead space or other conditions which trap fluid, prevent effective cleaning and may allow microbial growth to take place. In case of pipe fittings, pipe unions present a weak point in any system. The DIN 11851 standard is used for pipe fittings. In Hygenic Piping design, but welded bonds provide an optimum safety when they are a result of any gas welding. Should a solid joint not be desired on whatever technical grounds, screw or clamp joints now come into consideration. The standard design for a stainless screw pipe connection as per DIN 11851 requires a profile jacket. In this type of construction, there is always a crack between the socket and the thread. This disadvantage can be avoided by using a special profile gasket. An alternative is a clamp union, called a tri-clamp. This consists of two identical clamp ferrules and a profile gasket, and is designed to avoid cracks, having them pre-stressed at a design tension. The clamp joint can also be opened and closed without using a tool. This is a typical 90-degree elbow. Both ends are either bare or can be clamped. The sizes are 8 inches. This is a typical 90-degree sweep elbow with union on one end and clamp on other end. The sizes are 8 inches. This is a typical 90-degree sweep elbow with external threading on one end and clamp on other end. The sizes are 8 inches. This is a typical 45-degree elbow. Both ends are either bare or can be clamped. The sizes are 8 inches. This is an equal T. All ends can be clamped. The sizes are 8 inches. This is a reducing T. All ends are either bare or can be clamped. The sizes are 8 inches. This is an equal cross. All ends can be clamped. The sizes are 8 inches. This is a tank welding ferrule. One ends can be clamped and other is but welded. The sizes are 8 inches. This is a concentric reducer. Both ends are either bare or can be clamped. The sizes are 8 inches. This is the eccentric reducer. Both ends are either bare or can be clamped. The sizes are 8 inches. This is an adjustable hand clamp. It clamps together to fittings that can be clamped. The sizes are 8 inches. This is a heavy-duty hand clamp with metal ring nut. It clamps together to fittings that can be sizes are in inches. This is a high-pressure clamp. It clamps together to fittings that can be clamped. The sizes are in inches. Valves are mainly butterfly or plug valves, used for hygiene application. These can be remotely operated using air pressure. Butterfly valves are available in tube only of 1 inch to 6 inches or 25.4 mm to 152.4 mm sizes. Pressure range is full vacuum to 140 psi by 9.6 bar. Temperature is up to 200 degrees Fahrenheit or 95 degrees centigrade. Ratings are based on valves using standard PDM, fluoroelastic, or silicone seat material. In a typical ball valve with clamp ends, filters or strainers are designed to promote product quality and sanitation, while protecting processing equipment such as homogenizers, meters, spray nozzles, needle valves, and pumps. These half-free flow designs are of stainless steel construction for sanitation and corrosion resistance. They have compatibility with a variety of woven and non-woven filtering media, and fast, easy servicing. Strainer is also a filter. However, it uses a perforated plate or screen mesh to remove larger particles from a processed stream. The major advantage of a strainer is that it is reusable. There are 3 levels of straining: A coarse, B medium, and C fine. When selecting a filter or strainer for your application, several parameters must be considered. Viscosity of the fluid to be filtered or strained, specific gravity of the product, operating pressures, temperature range of the product or fluid, specific processing goal, like items to be filtered out, particle size, etc. Compatibility of filter media and product, including O-ring and can lock materials, service cycle dimensions at point of installation, line size, and types of connection components. Good sanitary design features. These may be summarized as those which avoid chemical, physical, or microbial contamination of the product. This means, for example, that there are no places where the product lodges, builds up and then falls back into the product stream. It also means that the component parts of the equipment are either accessible for cleaning and maintenance, or are completely sealed. Give maximum protection to the product from extreme contamination. Simplifying cleaning. Pipe work requires good sanitary design and installation because apart from conveying material, it is part of the overheads which collect dust and dirt. Badly installed or maintained pipe work can be expected to leak and may be a source of direct contamination. If the material is suitable, like liquid sugar, be a pest control problem. Also, pipes going to and from the flow plate should be stopped, otherwise it will contribute to the wastage of the product. The type of support used is important to minimize dirt accumulation and make your cleaning quicker. Piping should be installed at least 150 mm or 6 inches from walls and floor to provide for thorough cleaning around it. When the pipeline is being installed, which encompasses the use gaskets, be sure that the correct gasket is used and that the pipe work and couplings are both correctly aligned and tightened. sanitary pumps are so made that the impellers, gear, the pistons can be easily removed or cleaned, thus making them adaptable for handling hygiene products. The pump may be fitted with a friction seal instead of packing, and the body and rotors of the pumps are made of white metal, bronze or stainless steel. The pump housing is fitted with sanitary pipe connections. All metal pump parts having any surface in contact with the product shall be constructed of metal consisting of stainless steel, nickel alloy, or equal to erosion-resistant material that is non-toxic and non-absorbent. All product contact surfaces shall be finished to an equivalent of not less than 120 grit finished property applied. All outside surfaces shall be smooth and easily cleanable. Exteriors of structural parts not in contact with the product shall be of corrosion-resistant material with a smooth finish or shall be rendered corrosion-resistant or painted and shall be so constructed as to be easily cleanable. Inlets and outlets shall conform with the sanitary standards for fittings. Seal shall be of the sanitary type easily removable for inspection and cleaning, and shall be constructed of material not injurious to food products. Single service gaskets of the sanitary type or removable rubber type gaskets that can be easily cleaned shall be used. Glass pipes and fittings made of a special top Pyrex glass is available in the market, and a number of successful installations are in use basically for the dairy industry. The glass pipe is endorsed for two principal reasons. First, as a substitute for stainless steel, and second, because it can be used in many locations without dismantling for cleaning, thereby saving considerable labor and clean-up time. The transparent nature of the glass makes it possible to examine the pipe visually after cleaning by circulatory methods, and detect deposits if there are any. Standard stock sizes are 1 inch, 1.5 inch, 2 inch, 3 inch, 4 inch, or 6 inch inside diameter. Lengths are up to 10 feet. Longer or shorter lengths are specially made. Normal operating temp, 0 to 212 degrees Fahrenheit or 100 degrees centigrade. Plastic pipe and tubing. Plastic sanitary tubing is now available in a variety of sizes from 1 by 8 inch to 4 inches inside diameter and in different weights. The popular brand Hygenic B44X, for example, was designed to convey processed milk and milk products. It is claimed to be non-toxic, fully transparent, and flexible at temp below 0 degrees Fahrenheit. It will withstand temperature and sterilization. It is resistant to milk and food acids and strong sanitizing agents. The following are standard sizes of plastic pipes and tubing: 1 inch, 1.5 inch, 2 inches, 2.5 inches, 3 inches, and 4 inches. Pipe and system designed for in-place cleaning. Many food equipment cleaning processes are now being conducted by recirculation techniques, utilizing a combination of chemical and physical effects to remove the soil from the product, contacting surfaces. This procedure is referred to as a CAP or clean-in-place operation, and process system, valves, and process equipment susceptible to this technique are said to be of CAP design. In-place cleaning is based on taking the detergent to the equipment rather than taking the equipment to the detergent, as has been the case with manually clean take-down lines. The effectiveness of the procedure is largely determined by the factors of time, temperature, detergency, and physical action involved. There are considerable benefits to be enjoyed through use of these products. with particular emphasis on reduction of cleanup labor cost, improved sanitation of the complete system through the ability to use higher temperatures and stronger detergents, and the elimination of recontamination when assembling dismantled equipment. In general, the development of a CAP program involves 7 steps. These include the determination of process line requirements, the development of CAP circuits, the design of a suitable supply return system to clean these circuits and handle also all mechanical spray cleaning operations, the selection of materials for construction, the making of the actual installation, the selection and installation of recirculating equipment, the application of instrumentation and controls to assist in continuous maintenance of the desired cleaning program and the desired results. Process piping requirements. Layout of CAP lines for processing operations requires attention to numerous details such as location and utilization of every pipe for both cleaning and processing functions, permanent installation of the greatest possible amount of pipe, elimination of all unnecessary bypass and return connections, provisions to enable all processing to be completed without piping changes yet permit quick conversion to the cleaning circuit. Plant layout. The ideal plant layout integrates the departmental areas in a logical way to provide for a smooth flow of materials and services. Plant layout basically depends upon the amount of land space available, shape of the site particularly with respect to road and rail access. It must be noted that a good layout does not require lavish or luxurious buildings. It does mean spending so as to maximize the probability of good management producing safe, wholesome food economically. Production section layout. Good production section layout is crucially important in order to minimize the risk of cross-contamination, which is a high risk for public health and product spoilage. It is important to separate microbiologically high and low risk materials and processes, personnel working with high and low risk materials and processes. It is also important to prevent cross-traffic between high and low risk materials and processes. When hygienic design was delivered, it should be noted that hygienic design is an intrinsic property of equipment, and later modifications to correct deficiencies are rarely simple, cheap, or wholly successful. Good hygienic design must deliver efficient performance of the intended task, e.g. mixing, heating, etc. No additional contamination of the product, chemically, physically, or microbiologically. Maximum protection of the product from external contamination and minimum contamination by the product of other equipment and plant structures. Cost effectiveness is installed for production, cleaning, and maintenance over the whole of its intended life when compared with alternative equipment. Basic principles of hygienic design. The most common design faults which cause poor cleanability are poor accessibility, inadequately rounded corners, sharp angles, and dead ends. It must be recognized that there are degrees of sanitary design generally related to the permitted tolerance of microbial infection in the final product. How to avoid contamination. One of the common features of poor sanitary design is the existence of inherent dead spots or dead ends. They are better described as fill traps. It needs to be remembered that microorganisms are very small, and that what is visually small to a human are to microbes the wide open spaces where they can multiply. Furthermore, if the cleaning does not remove material because design features show it, then this becomes a design source of contamination. It is therefore axiomatic that sharp corners, crevices, and dead ends anywhere in the product are unsanitary. Cleaning and sanitation are technologically distinct operations. However, since the objective is to achieve chemical, physical, and microbiological cleanliness, the combined operations are sometimes called cleansing, the term which is used in some milk and dairy legislation. Note that cleaning system components have both cleaning and sanitation functions. Bactericide, the chemical agent which under defined conditions of use is capable of killing bacterial cells, but not necessarily bacterial spores. It is important to understand that the use of a bactericide will not effectively remedy poor cleaning. Bactericide is a chemical agent which under defined conditions of use inhibits the increase in numbers of a bacterial population. Breakthrough chlorination, the point at which the chlorine demand of the water has been reached, after which the free residual chlorine concentration increases in nearly direct proportion to additional amounts of chlorine added. Buffer, the chemical agent or agents in solution which stabilize the pH. This is a measure of the acidity or alkalinity of the solution. During cleaning, the pH of a buffered cleaning is not much changed by dilution or small amounts of soil. Chelating power. This enables a cleaning solution to hold unwanted ions, such as calcium and magnesium, in solution or to re-dissolve precipitated salts. This property is important with hard waters, as calcium and magnesium can interfere with cleaning and emptying. Chelating agent S are organic compounds. Overview of cleaning systems. Responsible management accepts that cleaning is an integral part of production. It is therefore necessary to develop, implement, and maintain cleaning schemes that can be shown to be fully adequate and cost-effective. This requires definition of the cleaning task or job, selection of the optimal cleaning system, the application of managerial skills and procedures to define, assess, and change, if necessary, the chosen cleaning system. This will include written procedure for schedules and ongoing assessment for audits. Clean in place TAP is mainly used for cleaning liquid handling systems. It comprises a number of steps, drain the system of product, prepare the circuit S, e.g. by switching controls to clean, installing key pieces or flow codes, confirming availability of detergents, etc. Pre-rinse to remove product residues or gross soil. Circulate hot detergents to remove residual soil. Rinse with potable water of suitable quality. This rinse is the intermediate rinse with chemical sanitation and or acid scale removal is included in the CAP cleaning. It is the final rinse if there is no further step in the CAP cleaning. Sanitize to reduce microbial numbers to an acceptable level. Final rinse with potable water of suitable quality. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.